Hello everybody and welcome to Building a Second Brain. Today we are going to implement auto tagging, and this is a continuation of all the previous live streams that I did on the topic of tagging. So we're building a second brain application, and this is season 4 of doing that. And I mostly built this application for myself, but at one point I want to publish it, and a tagging system is just one thing that we need for that. So before we actually get into it, why don't you say hello, where you're dialing in from, and also which platform you use to watch this. So this is simultaneously streaming to YouTube, LinkedIn, and Twitter or X. Speaking of which, let me quickly check how the stream is doing on Twitter. It's not doing well, so if you can see this on Twitter, lucky you, because apparently Twitter can't deal with 4K video. So I'm just going to post a quick comment there, so folks trying to watch there can come over here to YouTube. If you're trying to watch this on X and it's janky, it's because of the 4K bandwidth. Join us on YouTube. Okay. And that's it. Cool. LinkedIn seems to be doing better. And you can't chat on YouTube. Why is that? Let me double check. So are you a subscriber of the channel? That might be a reason, but I might have turned off chatting. Let me just double check that for a moment. Manage videos. Live. Customization. Yep, so I've just turned it on for subscribers. Franklin, can you try again posting on YouTube to see if it works? If it doesn't, I'll have to try this again. Or open it up for anyone. Let's open it up for anyone. Yeah, it works. Amazing. I can see you. Great. And thanks for letting me know. Cool. And with that, I think we're ready to go. Cool. So what we did last time and the time before was I implemented a tagging system that allows me to say a specific link that I store in my second brain application can or is pertaining to a specific topic. So for example, this is a link that has to do with Swift or with Swift UI, or this here is something that has to do with Firebase. And at the moment, you'll have to fill this in manually, which is okay, I think. But since lots of things in this application are done with AI, I thought it might be worth implementing that with AI as well. So every time the user stores a new link, we can kick off a process that takes a look at the full text of the link that the user is storing and then computes all the meaningful tags for this link. And as a kind of stretch goal, why don't we also try to make sure that this process uses all of the existing tags that we already have, so that it doesn't come up with or prioritizes using existing tags, so that it doesn't come up with new stuff all of the time. So let's go into the screen share. And what you see on my screen here is my terminal and Antigravity. So we are going to use Antigravity for this. And for those of you who've tried using any VS Code-based IDE for Swift and iOS coding, you might know that one of the biggest challenges is getting the application to run on your device or on the simulator. And I have, let me bring my simulator onto this screen as well. Here we go. So the application is running here, but getting it to run here without Xcode is a bit of a challenge. So recently I came across a tool called Flowdeck. And let me actually show you. So flowdeck.studio. This is a CLI-based tool and also a plugin for VS Code that makes it really easy to interact with your iOS and Swift toolchain without having to go into Xcode. I personally don't mind Xcode. I quite like it. I like how it looks like, and I also think that it provides, I think it provides a good developer experience. I know that many of you might think, oh my God, Peter is suffering Stockholm Syndrome, and maybe that's the case, but I kind of like it. But anyways, Flowdeck makes it possible for you to interact with your simulators, with your application, and even with your devices just from the command line. So the way how it works is, so if I'm in the folder where I keep my source code, and now I can run flowdeck-i. Let's make this larger so you can actually read this. So I can run flowdeck-i. That means that it runs in interactive mode. So, and I've already done this before. So the very first time you do that, Flowdeck will try to find any Xcode projects in your folder, and then it will try to find the scheme and the target. So it will list all your simulators and all your physical devices, and you can also choose which configuration you want to use. So I've done all of that before, and this is why it says this is the Sofia app. We're using the Sofia scheme, and we're targeting an iPhone 17 Pro simulator, and we're using the debug configuration. So now I can press H to see all the commands that are available. And for example, I can press B to build the application. And you can see that it's now building the application and it's resolving the packages. And after a moment, it will tell us if this was successful or not. So let's give it a moment here. And since this is a moderately complex application, this takes a little while. So I think, I don't know if that was just like a result of me resizing the window, but I think it's done now. So let's try running the application. So I'll press R. Oh, sorry. So apparently there was a problem. So it's building, and then it should run the application on the simulator at any moment. And I see we've got our regular crew together. There is Lars, and we've got Franklin. Who else is here? Say hello. So now it's preparing the installation, and if I bring the simulator to the front, oh, I didn't want a screenshot, but anyways. And now the application starts, and in the background you can see that it's started up, and now we can also say we want to stream the logs. So here is our log view, and if I do stuff in the application, we will see that we can see the logs being streamed. So for example, if I go in here, we can see all sorts of log output, the attribute graph stuff, that is SwiftUI. Read is the library that we're using to render the web page on the screen, and all sorts of other stuff. So this is what you typically get in your Xcode log. Cool. So let's go and do a simple walkthrough. Instead of using Antoine's blog, why don't we, I wonder what's with John Sundell. Let's see if he has something. So Swift by Sundell. Ooh, he hasn't posted in a long time. Or maybe, have we gone to a deep link? Let's see. Back, that's 2025. Okay, maybe let's go to nil coalescing Swift. Here we go. Yes, thank you. And let's go to Natalia's blog. Okay, why don't we look at animating SF symbols? So let's say we've got this article here, and now let's save this to the application. Let's go and save it to Sofia. In the background, we can see stuff happening, and you can see that it's extracting the metadata from this URL, and it shows us the title, the site, the excerpt, and we need to add our tags ourselves. So this was something about Swift. And I really need to change that uppercase behavior. It's about Swift and SF symbols and what else? Animations. So I have to come up with all those tags, and that is just cumbersome. So what I want to do is we'll store this. And then if we go back to the application, it is in here. We can see our tags up here, so that's fine. So I want to automate the process of entering the tags. And there are a couple of ways how we can do that. So we can do that from the UI, right? So very much the same how we do the metadata extraction. We could say, okay, every time the user types in a URL or pastes a URL here, I mean, I can do that here. So for example, let's go to Donnie's blog. And I could go in and say, well, this blog post here is interesting. I'll copy it and paste it here. And then, boom, it extracts all the metadata. So there is a process that goes off and does that. And apparently, this happens from the client. At least that's what I suppose that's happening, right? We can take a look into the application to see if that's still the case, because different versions of the app did it in different ways. Or another way is to say, well, instead of doing that from the client, why don't we do that from the back end? So every time the user stores a link into their knowledge base, once it hits the database, we go off and fetch all the metadata, or we compute all the tags. And we already do this. So for example, you might remember in, I think in season 2, we implemented this. I implemented a feature where you can go and have a chat with the application, right? So for example, I can go in and say, how can I map data from Firestore? So what happens here is this will now go to the database and it will ask Firestore to retrieve all the best matching documents for the query, and then it will use those documents to populate a prompt and then return the result as an answer. And that is a traditional, typical RAG implementation, retrieval augmented generation. So you take the user's input, you find all the best matching documents from the database, you get them back, you inject them into a prompt, and then you send that prompt off to the model, to an LLM, and you get the response and you show that to the user. This is what's happening here. In order to be able to find the best matching documents, because this is not even a full text query, this is a semantic search essentially, you will have to compute the embeddings for all the documents that are stored in the database. And to do that, we use a trigger. So if we go into the backend, let me show that. So if we go into the backend, we need a trigger, and here it is. So we have an update embeddings trigger, and that will kick off every time a document is written to that artifacts collection. And then what it will do is it will get the data in the document and it will compute the embeddings. And this is where it happens. So we're calling ai.embed. We're using Genkit to do that. Genkit, of course, is Google's AI orchestration framework, and it can plug into all sorts of AI tooling. And in this case, we're using an embedding model to compute the embeddings. And then once we've got those embeddings, we store them back into the database. And that is what we're doing here. So we could do the same for tags, right? We could say every time the user stores a new link into the database, there is a trigger, very much the same like this one here. We could essentially just copy that. And once it is stored, we will go to an LLM and say, here is the full text of a URL. Here's the URL, here's the full text. Can you please suggest a number of tags that best capture the meaning of this article? So that would definitely work, right? And the advantage of doing that is we'd only have to implement this once. We'd only have to implement this once in the backend, and then all of our clients, no matter if it's iOS, Android, or the web, would benefit from that. And I know we don't have an Android app yet, but we do have a Chrome extension. So the Chrome extension would just be able to say, you know, I'm going to store the link into the database, and we wouldn't have to implement that feature in the Chrome extension because it benefits from the backend implementation. So these are all benefits of implementing it on the backend, right? But here's the thing. This is the entering the tags. This is something that is very close to the UI. So we are in this dialog here, and the user might want to type in their own tags. So instead of going to the backend and say, well, once it hits the database, we can compute the embedded the tags and then write them into the document. That's not good enough because, and let's do this again. So I'm going to take this link again, and then I'll go and add this here. So all of the state here is not yet persisted. So it's not stored in the database yet. So that means we can't use a trigger because it hasn't hit the database yet. What we could do, however, is to use a callable Cloud Function. A callable Cloud Function is a piece of code that runs on infrastructure that Firebase manages for us. And ultimately, it does run on a server, so it's not entirely serverless. But we don't have to manage that server because Firebase does it for us. And it automatically scales the server for us, right? So if we've got many, many people who are using our application, we don't have to worry about our backend implementation becoming a bottleneck because Firebase will automatically sense the demand and it will provide and provision more resources as necessary. And then if the demand goes back, it will automatically scale back down to 0 or to 1, depending on how you configured it. So a callable Cloud Function is like a HTTP endpoint. So you can just make a call, a remote call, from your client application, and that may be an iOS application, it might be an Android application, it might be a Chrome application, or a Chrome extension, or a Safari extension, or it can be a curl command that you send from the command line. And then in response to that request being sent, you can perform work on the backend and do stuff. So what we could do is we could go in and implement a callable Cloud Function that takes a request, and that request might contain the this entire document that we have here, this entire metadata document here, and we could then in that Cloud Function make a call to Gemini and compute all the tags. And that would definitely, so it would work. It would mean that we'd only have to implement it once, and it's easy to call, right? So calling a callable function is easy enough, and we actually do this in our application. So we have a feature for summarizing. So we've got our summarization feature. And in the summarization feature, we call a callable function. We did that in a previous version of the application. See, because here, what we're doing here is we're using yet another approach. So let me explain this approach here as well. So this approach here makes use of Firebase AI Logic. So what's happening here is, and let me show that in the application. So I'm in the application, and let's say I don't have time to read the article, so I can go in and say, please summarize this article for me. And then the application will make a call to Firebase AI Logic, and Firebase AI Logic essentially acts as a proxy for Gemini and it will forward the call to Gemini, which will summarize the text that we're sending, and it will then return the result. So, that is the high-level summary of what's happening. But in addition, if you remember what we did in a summarization service, we implemented a hybrid approach. And that hybrid approach makes use of Apple's foundation models. So let's find that place. So we have got a protocol called inferencer, and that inferencer has three main parts. So the first and most important part is the infer method. So that infer method takes an input and then it returns a result. And in this case, it gets the full text, and what it will return is the summary. It also has a field called isAvailable, and that is here in order to tell the application, is this inferencer available? And the reason why it's there is that on older devices, you can't use Apple's foundation models. So they're only available on modern devices. Or the user might have disabled that in the operating system. It's been turned off by a policy, for example. So this is why we need the isAvailable flag here. And then we also have the instructions, and the instructions basically are the prompt. And again, why do we have instructions? We might want to, why don't we use the same instructions for all of the inferences? Well, the reason is, for a large language model that runs on a server, it's probably more powerful than any large language model that runs on your local device. So on a local device, you need to use a more compact and more streamlined prompt that consumes fewer tokens than one that you can run on a server. And this is why we have the instructions. Cool. So, for example, here's our local summarizer, and local summarizer makes use of the of Apple's foundation models. So we start a large language model session here, and then we ask it to respond to the input, and we get the response and return that. And we also have a remote summarizer, and that remote summarizer makes use of Firebase AI Logic to then return the result that we get from the server. So now we've got all those different ways of doing things. And when I posted this this stream earlier today, I asked people what they think we should be doing, or what we will be doing. So let's quickly see what the result of that was. Okay, it only got 2 votes. One person said I was going to use foundation models, and the other person said something else. So I think what we'll do is we'll use a hybrid approach, because personally I think what we're doing here is very, very similar to the summarization feature, right? So we are in the UI, and we need to update the UI quickly, so we can't use a database trigger. And implementing a callable function would be possible, but it would also mean that we wouldn't be able to use Apple's foundation models. And maybe we want to do that, right? So if we can, why not do that? Because it's going to be slightly cheaper, right? So instead of going to the server and computing on the server, we can just compute on the local device, and it's going to cost us nothing instead of a few cents. Cool. So what we are going to do is I'm going to try to work out a PRD together with Antigravity and then see how well it understands the code that we already have, and then together with it try to implement this as a feature. So let me get my talk box. Okay, I'll put it up there so you can see it. Hello. Okay, it works. Hello. I want to implement a feature where the user can automatically generate tags for a link that they're adding to the application. So I first want you to analyze the existing application and understand where in the application the user can add new artifacts or URLs, and find all the places where they can edit the tags of a link. I then want you to analyze the iOS application to understand how it uses Firebase AI Logic and Apple's foundation models to compute summaries, because I want you to implement this new feature analogous to that summarization feature. Once you've analyzed the code, I want you to put together an implementation plan and present it to me for further discussion. And also, let's make sure to use Gemini 3 Pro. Earlier this afternoon when I was using Pro, it was a bit slow. Maybe there was too much demand, so I switched back to Flash, but this is already looking much better than this afternoon, so I think we can use Pro. All right, and while it's doing that, I'm going to take a sip of my tea. All right, maybe I was overly optimistic. Maybe we need to go back to Flash. Let's see. Alternatively, we can use Gemini CLI, because for some reason it seems that it has better access to the model. But it might just be me who's thinking that. Yeah, I'm excited too. I hope this works. Okay, I'll give it a bit more time. Okay. Yeah, I feel that you have to have a bunch of really good jokes that you need to be able to tell while the model is doing its work when you are presenting. Maybe I should write an app that produces good jokes that I can tell. But maybe I'll just switch back to Flash. So what we can do in the meantime, Gemini. So I'm going to see if Gemini CLI gets us faster results. So we've got 11 context files, 5 MCP servers. Let's see. Okay, so this is, yeah, so this is already slightly faster. Yeah. Yeah, okay. We will see once this gets back, but this one is doing better. I mean, it has trouble with some of the finding some of the code, but I find that it's always able to get back its bearings. So now it's analyzing the summarization service. Okay, so this is a wild race now. Who is faster? Gemini CLI or Antigravity? So Gemini CLI is now looking for the dialog that we use to edit the metadata, and which also contains the list of tags. And it's searching. Yeah, so I think this would benefit from having an AST explorer, so that the LLM could use the AST of the application to find the symbols more easily. So what it's doing at the moment is just using brute force search. That's okay, but less than ideal. In the meantime, Antigravity also is analyzing the summarization service and is trying to find the UI code. So they're both on the same page at the moment. So typically I wouldn't do this. I would only just use one, either Gemini CLI or Antigravity, but because Antigravity seems to be slow at the moment, I decided to use Gemini CLI at the same time to see who's gonna finish first. But also it will allow us to, or it will allow me to demonstrate one thing that I find quite, it's something that you should think about when you're using coding agents. And that is where to store your planning documents and requirement documents. So, Gemini CLI has come back with an implementation plan. So it says, I will implement an auto-tagging feature for the Sofia application modeled after the existing summarization service. This feature will use a hybrid approach, leveraging on-device AI using Apple Foundation models when available and falling back to Firebase AI otherwise. And then it walks us through what it's going to do. So it wants to create an auto-tagging service package, and that is great because we already have, if we look at the current structure, we have a summarization service. So it was able to understand our architecture and see that we are using packages to organize our code. So suggesting to implement a package is exactly the right thing to do, and it puts it into the correct folder. That's great. Here are all the files it plans to create: the package file and then a configuration. So that configuration we already have in the summarization service, and we use it to be able to use remote config to fine-tune the implementation. So it allows us to go into remote config and say, well, under specific circumstances, we only want to use the local inference engine, or we only want to use the cloud-based inference engine. So that's really, really good. And then it's even comes up with all the different keys that it would require in remote config to be able to configure that. And then we have the auto tagging service, and this will implement a strategy pattern. We will have a local auto tagger, we will have a remote auto tagger, and the local one uses Apple's foundation models, and the remote auto tagger will use Firebase AI. And these are strategies that are being used by the auto tagging service. So it completely understood how our summarization service works, and it's replicating that for the auto tagging. Then it will integrate this into the metadata UI, and that's this package over here. And this package contains the artifact editor view, and that is the dialog where we edit all the metadata. So that is perfect. So it will add an auto tag button to the tag section, and that's going to be interesting how that's going to look like. And that button will make a call to generate tags, and it will update the tags with the result. Cool. It suggests a prompt that it wants to use. Analyze the following text and generate a list of 3 to 5 relevant tags. The tags should be concise, 1 or 2 words. Output only the tags as a comma-separated list. Good. And then it comes back with a couple of questions, and that is super because that allows us to iterate on this. So, should we strictly limit the number of generated tags? It's a good question. Should we prioritize the full text of the artifact, or is the URL metadata excerpt sufficient? Full text is better for accuracy, but might be heavier. True. UI placement. Is a simple button next to the tags field the desired UX, or should it be automatic upon URL entry, like metadata fetching? And that's also a great question. So it did understand how the current UI works. Right? So in the current UI, I inserted a URL and it automatically fetched the metadata. And every time I make a change to that URL, it will go and refetch the metadata. Okay, so this is all great. And while I was talking, Antigravity also came back and said that it finished analyzing the code base, and it suggests to implement a tagging service. So let's take a look at that. So here is the implementation plan, and the goal is to implement an AI-powered auto-tagging feature for artifacts, allowing users to automatically generate tags for a link they are adding or editing. This feature will be architected analogously to the existing summarization service supporting both on-device and remote inference strategies. Ooh, that is interesting. So it says it's going to introduce a new package, and this will require updating the Xcode project. So this part here, that is not entirely true. Oh, it is. It depends. It depends. So because the way how we set up the project, it might be true, it might not be true. So the only reason why we would have to go into the Xcode project to set a dependency from our main Xcode project, which is on the Sofia app, where is it? Here. So this part here is if the application directly needs to use the new package. If it doesn't, and I believe that's the case, we can just define dependencies from the packages that use this new package here. And I believe that is the case, because really where we need it is in the metadata UI, just like the summarization service. So that might or might not be the case. So, and then it says it's going to create a tagging service, and it also suggests on the same folder, it will create the service, it will create the type so that we can distinguish between local and remote. It will create a protocol. It will implement a local tagger using VSLLM. What is VSLLM? Okay, it's all sorts of things, but nothing to do with, I mean, well, LLM obviously is a large language model, but BS, God knows. And then we'll have a remote tagger that uses Firebase AI. We'll use a tagging configuration for being able to remotely configure that. It will register the tagging service in the main application, and then it will use it in the artifact editor view. And it even suggests a couple of steps to verify this. Okay, so now I'm going to show you where each of the, or why I sometimes prefer Antigravity over Gemini CLI. So Gemini CLI, I think both did a really good job at understanding the application and analyzing the architecture and coming up with an implementation plan that literally is almost the same, and there are just small differences. So for example, Gemini CLI suggested to use auto tagging service, whereas Antigravity suggested to use tagging service as the name, but everything else is almost the same and it's very, very similar. So I'm pretty happy with that. But let's say we wanted to suggest a couple of changes, right? So for example, if I wanted to say, well, instead of naming it tagging service, I want to name it auto tagging service. I could easily go in and select stuff in this implementation plan, for example, by double clicking here and then adding a comment and saying, let's name this auto tagging service. So I can review this document and suggest changes. And then once I'm done with the review, I can send it off to Antigravity and tell it to rework this implementation plan. For Gemini CLI, that is not possible, at least not that I know, right? So I can't. So if I make a double click here, it will pop up this chat pop-up thing here. But if I click on that, it will basically just insert this into the Antigravity chat. So that is not useful. So if I wanted to make any changes to what Gemini CLI is suggesting, I would have to use the chat box here. So I'd have to type in, oh, let's name the service differently. And that's completely fine. And it works. But I find being able to use this annotation field here much more convenient. So I actually think that TaggingService is a good name. But let's say yeah, okay, so what about the magic wand? And does it say anything about the UI? Oh, it does. So even that is very similar. So it didn't have any follow-up questions. So let's use the fact that we had some follow-up questions here to improve our implementation plan. So I can go in and say, let's find the correct place. So I'm going to use this here and say, in addition, I also want to make sure that when the user first enters the URL, we automatically suggest tags. And then what else? Appended or replace existing ones. We'll append by default. Yeah, that's great. And then here I can say, are you sure that this is actually required? So add this, and then let's review this and see what it comes back with. So hopefully this is faster now. While we're waiting for this to come back, I can actually show you this wonderful t-shirt here. And that is a teaser for a live coding show that we're going to do on the Firebase channel later this week. So the name of the show is Code, Commit, Deploy, Repeat. And Marina and I will run the show, and our plan is to implement an application from scratch and get to, every issue. We will implement a feature. We will commit it to a repository so that you can see it. And once we've got something that we can deploy somewhere, we'll also do that. So either we're going to deploy it on the cloud, or if it's a mobile application, we will upload it to TestFlight or to to the corresponding Android equivalent. And so you can try it out, and then we'll repeat that over and over again until we have a full application. And once we've built one application, we'll do it again with the next one. So hopefully it'll be a lot of fun. And so for the first season, we're planning to do a productivity application, and then we'll see where it takes us, and we'll see what people want to see, and maybe we'll implement something entirely different in the next season. Who knows? Maybe people want to see how to build games with Firebase, and we'll bring in 2 other hosts to make it interesting and varied. So code commit, deploy, repeat. This, let me double check so I don't tell you anything wrong. Let me go into my calendar. So it's this Wednesday, Wednesday 28th, and we will go live at 18 o'clock Central European time. I would be thrilled to see many of you over there. So we're now updating the implementation plan. So it's still working. And since we're getting results here, we can make the window larger. Right? Whoever works gets space, right? So here's our updated implementation plan. We will add Firebase AI and Firebase Remote Config dependencies to the metadata service package to support the tagging functionality. That's great. And then auto tagging on entry. Okay. I think this all looks good. So, and I already created a branch. So we are on the auto tagging branch. So we can go ahead and have it implement this. So we've got the implementation plan. Yeah, great. So let's proceed. Oh, no. See, it's always good to double check. So it wants to reuse the metadata service. Is that a good idea? Let's ask about that. So I want you to give me 3 reasons for keeping this in the metadata service and 3 reasons for putting this into a separate service. And while it's doing that, let's think about them. So one reason for putting it into the metadata service is to obviously keep everything in one service and not add any additional dependencies. So that's going to be easier, and Antigravity will be able to implement this entire feature just by itself, and it won't even have to ask the user to please go into Xcode and add new dependencies as packages to the main application project. So that is one reason for keeping it in the metadata service. Another reason might be that tags are metadata. So we can rightfully say that this belongs into the metadata service. So that's also a good reason. we're also using much of the infrastructure that the metadata service is using. So again, all good reasons for doing that. One reason for putting it into a new package might be to say, well, this is slightly different than computing the metadata by just extracting it from the HTML, right? So because if we, the way how the metadata service currently works is we give it the entire HTML and it will then make a call to a library that extracts all of the metadata from that HTML. And that library performs all of that locally in memory. And what we're doing now for the tagging service is different because we are making a call that potentially goes to a remote service. So we might be using Firebase AI Logic, which is a remote service. We might be using a local LLM, and that would be a local call. So, and that, because this architecture is slightly different, it might be a good reason to put this into a new package. So let's see what Antigravity thinks about this. So trade-offs. Conceptual cohesion. I love how it is much more eloquent when talking about these things than I would ever be able to communicate. So it says the same thing like I did a couple of minutes ago. Tags are fundamentally metadata about an artifact. Yeah, data locality. Metadata service already fetches and processes the article content. And simplicity of integration. Yep. So, a separate tagging service, dependency weight. So the metadata service currently relies on lightweight libraries like SwiftSoup and Read, and these are local dependencies. Tagging requires Firebase AI, which are heavy dependencies. Integrating them forces metadata service to carry the weight of the entire AI stack, forcing any consumer of metadata to also link against Firebase. That's a valid point. Separation of concerns. Deterministic versus probabilistic. So extracting the metadata is deterministic because all of the information is already there. Computing the tags is probabilistic because we are using a large language model. And reusability. You might want to tag content that isn't a URL, for example, a user type node or a journal entry. A separate tagging service can be reused for any text content, whereas metadata service is tightly coupled to ingesting URLs. And that is an extremely good point. Yeah. So I am definitely planning to allow users to store other things than URLs in the database, and type nodes or even documents like a PDF file are things that I'm considering. So this part about the reusability here is a very strong factor. Yeah, and so it says, well, I suggest keeping it a separate service. So, and that's what I'm going to go with. Also, did you notice, even though we started the conversation from the review here, it answered in the chat window because it is much better to present those alternatives in a chat so we can make up our minds than editing the implementation plan and us having to understand where to find the information. And this is imagine that this would be a much larger implementation plan, for example. So this is a really good way to have this conversation. Let's implement a tagging service. You've convinced me with the point about reusability. Please update the implementation plan and present it to me for final approval. So let's see what it comes up with. So plan is updated. Let's do another review to make sure that it actually does what we want. So dedicated tagging service will be reusable for any content type, but primarily used to automatically generate tags for artifacts when a URL is entered. It will support both local and remote inference strategies, keeping the AI logic decoupled from metadata extractions. So a new local Swift package called TaggingService with the TaggingService class, an inferencer protocol, a local and remote strategy. The API will be called generate tags for content, and it will return an array of strings. Oops, we don't have this file yet. Okay, and all of this looks good. Auto suggests, verification, good. Okay, I think we can go ahead. So I'm going to proceed, and now we can go and have a coffee, or tea in my case. And we can watch as it chugs along. We can even open our agent manager. And here we are. So if we were to work on other stuff at the same time, for example, if I wanted to continue working on my blog in the meantime, I could totally do that. But let's keep watching what it's doing here. And actually, I like watching this a lot more. So the interesting thing here is that it's now resolving packages. So it's opened a new shell inside of VS Code or Antigravity, and it's resolving a package. Yeah, so it's resolving the tagging service. Wow. It already finished. Really? So I think let's keep this open. So it's created the files for the tagging service. And now it wants me to add this to the Xcode project. So let's see if this is anything that Flowdeck can help us with. So packages and project commands, P. Swift packages, list installed packages. So here are the packages that we've installed to the main project. And you can see that these are all just third-party dependencies and none of our local packages. So I can press escape to go back, I think. We could add a Swift package, and that requires a URL, so it doesn't seem to support local package management. But what we can do is I can tell it to open the project in Xcode, and then we'll do that in Xcode. So let me see what it wants. File, add package dependencies, and then add local and add the tagging service. And once we've done that, it wants me to tell it so it can proceed. So, yeah, so as you can see, in the list of all the local packages, we have all the local packages, apparently, but not the new one. File, add package dependencies. File, add package dependencies. Add local. And then we need to navigate to the correct place. Let's see, Sofia code, live stream, auto tagging, that's correct. Packages, and then tagging service, add package. Oh, that is interesting. So it wants me to add the tagging service library to the Sofia target and also add it to the metadata UI target. So let's first add this. Pulling local packages into Xcode, you can do that in multiple ways. So one way is what it's doing here, but you can also just drag and drop. So let's see, we're going to add this to the Sofia target, and we can't add it to the metadata UI target as it's suggesting here because that's not listed here. Add package. So does it show up? No, it doesn't. Or maybe it's still resolving. Yeah. Oh. So can you see? You can't see that. Yeah. So the way how we added it resulted in the package dependency being added here instead of being added here. So that's not what I want. And that is why I am going to remove that. And to do that, I'll need to go to the package dependencies and remove it here. But instead, I'm going to drag it in right from the Finder. So let's go into the correct folder. We've got our tagging service here. So, and then I'm going to drag this and bring it into the Xcode window. And then let's see if I can add it below the metadata service, like here. So reference in place. Okay, this looks good. So this part here, also add tagging service to the metadata UI target. This feels like something that Antigravity should do for us, because that is literally editing the package file. And we can tell it. Okay, I've added this to the Sofia application, but honestly, I think you should be able to add it to the metadata UI target yourself, because that quite literally is another Swift package, and you should be able to edit the package.swift file of the metadata UI package. We can even point there. Like, can I do that? No. But we can do it like this. So add package.swift, and then we'll just need to find this. So let's see if that was convincing. Yep, here we go. So it made the change. And what else is happening? It's resolving the packages. Nice. And it's now working on updating the artifact editor view. We can have a look at that as well to see what it's doing. Okay, so it's importing the dependency, and then we can use the minimap to go to where all the changes are. So it's pulling in the singleton. It updated the code to generate tags when it is in when the editor view is in add mode. So we can either edit or add a URL, and this is what the presentation mode is about. Oh, I wanted to continue reviewing the code here. And here we've got our generate tags method. This code looks good to me. So it makes a call through the tagging service, and then it checks if we do have any existing tags and makes sure that if there are any overlaps, that it doesn't duplicate them. Yeah, so this looks good. Oh, and then it also added a button that we can press to generate new tags. Cool, so let's take a look, because it also opened the walkthrough for us, so we can take a look at the walkthrough. So that is basically the summary of what it did for us. This walkthrough demonstrates the new auto-tagging feature for Sofia powered by the TaggingService package. So it said that it implemented the service. This is the core service. We use a local tagger and we have a remote tagger. We have a configuration so that we can specify how to use them. It added a dependency to our UI. The feature will automatically trigger tag generation when a new artifact is generated. There is a magic wand that we can press if we want to regenerate tags. And there is a loading spinner to inform the user that work is being done in the background. So for verification, it suggests we should run the application and just give it a try. That's always a good recommendation. And after we've tried a couple of use cases, it also suggests that we can try out the remote config configuration. So let's first give it a try and see how well the implementation works. So we are back in FlowDeck, and I'm just going to press R to run this application again. So fingers crossed that this compiles without a hitch. So far, so good. It's resolving packages. So let me move this a little bit over so you can see better. I'm really quite happy with what it has achieved so far. So the build seems to work. So no compile errors, which is great. Launching the application. Let's bring the simulator to the front. Here we are. And let's see, do I still have Donnie's article in the paste buffer? Probably not. Okay. I'm going to paste this here. We get all the metadata. What? This is amazing. Did you see that? I mean, like, it obviously should work, but I'm still, it still blows my mind. You could say that I'm easily impressed, but color me impressed. This is great. So let's save this. This is fantastic. Let's go to this one here. So if you haven't read this yet, this is the newsletter that came out just today. And in it, I advertise for this live stream. So should I click on the live stream now to watch the live stream while I'm doing the live stream? We need to go deeper. But what I want to do is I want to take this and see which tags it suggests. So just to demonstrate, a tags field is empty. I'm pasting this and boom, Swift, Todoist, async stream, AI and skills. And that is really good because I have got a link about Todoist in there. And we also talk about async stream, about AI and skills, and Swift, of course. This is really good. So one more, firebase.blog. And let's look for something entirely different. Yeah, so debugging native crashes on Android just got easier with Crashlytics. So this is completely different from anything else that we've got. So let's copy this as well. And then insert it here. Android, Crashlytics, Firebase, updates, tutorials. That is really good. Really, really good. Let's see what the New York Times has cooking today. It's not pretty, is it? Okay, let's take this one here and then see what it does. Okay, refugees, immigration, detention, lawsuit status. Yep, that seems to be accurate. Let's take another one. Okay, lots of snow. Let's take this article about the weather. Snowstorm, power outages, fatalities, cold temperatures, live updates. Yep, that seems to be accurate. Nice. So, I think this works really well, and I'm really, really happy with how well it worked. And you know, we didn't have to implement anything ourselves. Everything is just completely vibe coded here. So what I now want to do now is let's check this remote configurability. You can tweak the prompt or enable or disable the feature using Firebase Remote Config console variables. So let's go into the Firebase console. And then I'm going to, here is remote config. And now, so we've got our summarization feature here. And I want to create a new group to keep this together. So this is for tagging. The auto tagging feature in Sofia. And then we can add a parameter to this group, and this is tagging enabled. It is a Boolean, and let's say it is enabled by default. That is nice. And then what else do we have? Tagging priority order. We can add that as well. So add parameter to group, tagging priority order. Let me see how we did this over here. So this is the enablement state, instructions. So this is a JSON. Okay, and it's just written as an array, So add parameter, tagging priority order, JSON, and then we could have just copied this. So first try to use local if and then remote. So let's publish those changes. And look at that. So I've just turned on the logging output in Flowdeck, and it showed me that the ooh, that's interesting. Oh yeah, that makes sense. So all of the packages that use remote config get all of the remote config parameters. So that means that even though the tagging enabled parameters only useful in the tagging configuration context and in our tagging service, the summarization feature also gets to see it. We're just not using it over there, right? So, but the tagging configuration received the updated keys, which are tagging enabled and tagging priority order, and then successfully activated and updated properties from real-time update. Well, okay. I mean, the summarization configuration probably didn't really update anything. So, I mean, that's probably no change at the moment, but let's try turning this feature off. So, tagging enabled, and we'll just turn this off. Save, publish, publish. We should get an update here. Or maybe not. So I am going to, that doesn't work. Okay, it took a while. Does that still count as real-time configuration updates? So event triggers and generated admin SDKs. Let's add this. So now, since I've turned this off, the tags should not be computed. And there you go, they were not computed. What happens when I tap this button? Nothing happens. And we get an error output because it says the feature is disabled. So now let's enable the feature again. And here we go. True, save, publish changes, publishing changes. So now it's activated. And here you go. Firebase event admin SDK news. That is correct. Nice. This is really great. So we've been able to implement this nice feature thanks to the help of Antigravity and a little bit of help of Gemini CLI, mostly to come up with a couple of ideas that we should make sure that we also implement. Resolve packages, yeah, we don't need that anymore. Let's close all of those windows and then let's take a quick look at what at all the code that got generated. So we have an update to our metadata UI package.swift file to set the dependency on the tagging service. We have an update on the artifact editor view, and there are a couple of changes here, a couple of changes here. This is the code that generates the tags. And I also like that it structured the code exactly like we did before. That is really, really nice. Here is an update to our UI. And I think that it did an okay job at integrating this with the UI. It feels natural to the UI. I mean, it could be nicer. For example, wouldn't it be nice to have like this kind of like Siri like gradient overlay that you get when you activate Siri? That might be a fancy way to demonstrate, oh, we're working on updating the tags now, but you know, for now it's fine. We can always improve that. Then we have the package file for our tagging service, which defines a dependency on the Firebase iOS SDK. And I really love that it automatically detected that we are currently working on this branch here, which contains the code for async sequencer support that I added a couple of episodes ago. That is fantastic. So, and then we've got our tagging configuration, which is our remote config integration. And here you can see all the different configuration keys that it supports. We've only been using the tagging enabled key and the priority order, but there are other parameters as well. So that, for example, we can use different instructions for the local and for the remote tagging, which is pretty cool. Here are the default instructions that it uses. And these work really well. Then we've got our tagging configuration, which uses real-time remote config. And we've got the tagging service, which does the actual work. So here's our tagging inferencer, which has the infer method, which takes a string. Oh, that is interesting. So instead of returning an array of strings, it returns just a string. That is interesting. So that means that the caller needs to split the tags comma separated. But yeah, here we're calling the language model. So this is Apple's foundation model. And then here we use Firebase AI Logic. And we're using the model name that we get from the configuration. Yeah. So, and then the tagging service is being configured with our two strategies. So we've got an array of inferences, and it uses the local and the remote tagger. And then when we invoke generate tags from the UI, first of all, it will check if the feature is enabled in our configuration. If it is enabled, it will get the priority order, and then it will loop over the inferences in the order that is either predefined in the application or remotely configured. And then it will try to get the respective inferencer, run the inferencer, get the tags, and if that was successful, it'll be done. So it will not run both inferences, it will just use the first one. Oh yeah, and here it will parse the tags to split by the return values by commas. Nice. So this is really cool, and now we can take that and commit this back into the branch. I'm really happy with what you've achieved, and I want to commit this into the branch. Can you please suggest a commit message that outlines the changes that we've made? And here we go. Implement AI-powered auto tagging service, introduces a new tagging service package and integrates it into the application to provide intelligent tag suggestions for artifacts. It outlines the changes. That's great. And would you like me to go ahead and run the commands to create a new branch and commit these changes for you? We already are on the correct branch, so you can just go ahead and commit into the branch and then create a new pull request for me. Also, while we're at it, github.com, let's go into let's go, where's the project? Here we go. So here is our project, here is the status board, and I moved the AI-powered tag suggestions and auto-suggest tags when adding new artifacts to the ready state. So I want to make sure that it closes those. Please also take a look at the connected GitHub project to find the 2 feature requests that are addressed by our changes and make sure that these are closed when we merge the pull requests. If anything is unclear, please come back and ask me. So it's now using the GitHub MCP server to find the corresponding issues. So issue number 210, let's see, so it's 210 and 211. Nice, so it found, yep, so it found 210 and 211, and it will add the closest number 210 and closest number 211. Staging the files, committing, and pushing to the remote repository. Nice. So that means any moment now, we should see this here. So we've got the branch that had changes, and now it's creating the pull request, waiting for command status. And here is the walkthrough. Successfully created the pull request. So where is our pull request? Here it is. Implementing AI-powered auto tagging feature. Gemini Code Assist jumps in, and now let's see what it thinks about our changes. So it provides a summary, and then in a moment, it will let us know all the shortcomings in our code. This is something that I really find hilarious about working with Gemini CLI, Antigravity, and Gemini Code Assist. So you implement something and you think, oh, that's a really good implementation. You push it to the repository, and then Gemini Code Assist is like the most critical code reviewer ever. And it's like, did you think about this thing here? And that thing is not entirely super safe. And this one here, that might be a problem. And have you thought about this? And this one here. And it's really funny. And then you think, oh yeah, let's work on this. You instruct Antigravity to fix that for you. You push back into the repository. Gemini Code Assist runs again and says, that is a great improvement, but here are 5 other things that you completely forgot. So, yeah, it sometimes takes a moment Okay. Ooh. Yeah, so this pull request introduces an AI-powered auto-tagging service, which is a significant new feature. Okay, so it's very positive, it's well structured. However, there are a few areas that require attention, particularly regarding dependency management. That is surprising. Platform targeting and the inclusion of development artifacts. Yeah, so the debug log, that should be removed. So then it talks about the dependencies. Using print for error logging. What's happening here? Relying on a specific branch. Yeah, no, this is fine. This is fine. And we deliver. Why? No. So my monitor wants to go off. Please don't. Okay. Power off in 5 minutes. Deliberately use this branch. Oh yeah, I can say I don't want to go into standby. So we can resolve this. And then the other ones look good to me. Can you please check the review comments on the pull requests and let me know what you think about them? So, it removed the debug log. That's great. Interestingly enough, it did not address this one. Oh, it seems like it's only looking at the critical and high priority ones. That's okay. Nice. I think we're done here. Awesome. Can you please merge the pull request? So it seems like it is going to use squash and merge. Yep, so it's going to squash. So that has gone through. Yeah, pull request has been merged. And let's see the status board, and our in progress items now have been moved to the done column. Where are they? Where is 210 and 211? Here is 211 and here is 210. Nice. So, and these should also link to the pull request, so we can always go back and trace back to where this is coming from, which is really nice. Yep, and Antigravity was nice enough to verify that the linked issues have been closed. Awesome. So, and then as a final step, let me see if I can even deploy this to my phone. So I'm going to connect my phone. Yep. And then let's give it a bezel. Come on. So this looks nicer. So help. I want to select a different target, T. Nothing's happening, or maybe something is happening, I can't see it. Oh, here we go. It just took a long time. Cancel. No, come on, T. Okay. Oh, you just need to be patient. So this is an iPhone 17 Pro running iOS. So let's select that. And now in the bottom bar, you can see that it is selected as my target, and I can now press run to run this on my device. And in a moment, we should be able to see the application starting up on my phone. The interesting thing is, Flowdeck is free if you want to use it in an IDE, and it's a paid subscription if you want to use it on the command line interface. The cool thing also is that you can connect it to your coding agent. So it does have a skill, and that means if you make the skill known to your coding agent, the coding agent understands how to use Flowdeck in order to perform all of the tasks that Flowdeck can help with, like running an application on the device or getting a more streamlined view of your logs and stuff like that. Okay, so, I can't click on the screen, so I need to use the phone, obviously. So here we go. Let's see, Chrome. Oh yeah, let's go to Swift with Majid. What? Swift Majid. Okay. Monitoring app performance with Metric Kit. Okay, so streaming sounds interesting. Let's add streaming to our knowledge base, and the auto tagging worked. AI features models streaming, nice. Let's try a different one. Let's look at feature flagging. Let's add this, and Swift feature flags, build configurations, functionality toggling. Yeah, so I think this all is really great. Actually, let's add this because why not? Add and go back into the application. And here we are. And here are the tags. Sweet. Nice, nice, nice. So, and with that, I think we can wrap it up. Next live stream, next Monday, February the 2nd, 8 o'clock Central European Time. And there's still a bunch of things that we need to work on our tagging solution. So I want to have a better UI that shows us all of the tags that are available. And that's something that I'm going to implement next time. Yeah, thanks for tuning in and sticking with me. I'm really happy with what we've been able to achieve today. And I will see you in the next one.